Let's now look at the function y equals x minus 3 times x squared plus 2x plus 12. This thing can never be 0, because if you put this into the quadratic formula, you end up with a negative under the square root. Okay, set this equal to 0, do the quadratic formula, you don't get a solution, so it can never be 0. We call that an irreducible quadratic. That means it can't be factored. If it could be factored, then each factor would be linear and would give us a 0 in the same way that the linear factors of the previous function gave us zeros. But that's just not going to happen. So we also note, if we multiply this out, that the form is ax cubed plus bx squared plus cx plus d. And that's pretty obvious. Just multiply this thing out using the distributive law and you will end up with a polynomial of this form. So we see from before, from the previous example and the present example, that a polynomial of this form, a cubic polynomial, can either factor into two linear factors or a linear factor in an irreducible quadratic. Now I said they can either factor into these. Maybe there's something else they can do, but it turns out that there isn't. It's linear factors in irreducible quadratics, and that's called the fundamental theorem of algebra. It's a very important idea. In any case, if we want to graph this, it's really fairly easy. There's only one 0. That happens when x equals 3, so we plot that. We plug in x equals 0 to get the y-intercept. Negative 3 times 12 is negative 36. So we have y-intercept down here. And again, 3 is the only 0. We can check the far right and far left behaviors, as it's called. If we come out to the right along the x-axis, x becomes very large. Both of these are going to become very large. And we're just going to go off toward infinity. And if x is a large negative number, then we have a large negative number here. X squared is going to give us a large positive number, and if x is big, x squared is going to be a whole lot larger in magnitude than 2x. We say that the highest power term dominates this thing, and that's all we've really got to look at, is the fact that we got an x squared here, and see that for large negative, x squared is a large positive. That tells us as we go through large negative numbers, eventually we get to a point where this is always positive. This is negative, so this product will be a negative times a positive, which is a negative, so we get large, increasingly large negative values. And we have a graph that looks like this, turns out.